All right, practice 2, A, B, C, D, E. So for the first one, first thing is we got an 8 outside the bars. We got to subtract that. We get 7. Now from here, we can set up our two equations. One is equal to its pretty much the exact same thing, and the other one is to its opposite. Now, because there's nothing inside the bars, we get our two solutions here. Now, letter B. Yes, I have a 5 inside the bars, but because when I see it equals a negative 15, I can stop and say we get ourselves a no solution. There's no way to take the absolute value of something and get a negative in return there. So we cannot equal negative 15, and we say no solution. Letter C. All right. X plus 4 less than 9, and x plus 4 negative 9. Flip it. Subtract 4 from both sides. Subtract 4 from both sides. As I go to make a graph now of my two inequalities, doesn't need to be anything fancy. They're both going to be closed. I want solutions greater than negative 13, solutions less than 5, and I can see that they overlap right there in the middle. So right there is where I'm going to shade in between, and anything in between negative 13 and 5, it's inclusive. So those are solutions as well. And if you're not sure if you get the right answers there, you can always pick a number inside of there. If I pick a 0 and plug it in back into the original, I can just check to make sure I did shade properly. And absolute value of 4 is 4. 4 is less than 9. We do have a true statement, so it looks like we're good to go there. On letter D, I'm going to do the same thing here. Add 1, divide by 3. Watch your arithmetic. Let's go to the go to the number line, not calculator, number line. Negative 13 over 3 and 5. They are both open. I want numbers greater than 5, and I also want numbers less than negative 13. So this is, I should say this is our or in between here, and the other one was our and. And yeah, that is our solution set, okay? So I'm gonna highlight that a little bit better. Our solution zone is either to the left or to the right. Let me do the different color. Anything in between there, and negative 13 and 3 and 5, those are no solutions. And for the last one, letter E. Letter E, I see it is set to a negative 1. So with it set to negative 1, I want to keep in mind one of my two possibilities. Either no solution, or it's going to be infinite solutions. Now, which one is it? Well, I will go and take a number and plug it in for x there. So I want to see then if we have a true or false statement. I always take 0. 0 is an easy one to work with. Absolute value of negative 9 is 9. And then you ask yourself, is this a true or false statement? 9 is greater than negative 1, and that is definitely true. Therefore, we have infinite solutions, and we would shade literally everything on a number line. Now, if it was the reverse of that, less than negative 1, this is where you would get a no solution. If I plugged in 0 again, I get then a false statement. 9 is not less than, 9 is less than negative 1 is a false statement. So that would give me a no solution. So let's just make sure as we work through things, we know when we use an infinite solution or we use a no solution. So anytime I see it set to negative, that's what I'm doing. I'm plugging into x as 0 and seeing if we have a true or false statement. True statements give me infinites, false statements give me no solution.